Hello students, hope you all are doing well. So today, welcome you all to the lecture number 6 where we will discuss about the wave motion. In the previous lectures, we discussed about everything related to oscillation, damped oscillation, free oscillation, forced oscillation, then how energy decreases in damped, what is resonance, and all these concepts we have already completed. So today we will discuss about wave motion. So first we will discuss what is wave. And here in this lecture, we will discuss about what is wave, what are the characteristics of waves, then what are the different types of waves, and one more thing we will discuss, that is the wave equation as well as its differential form. So this is just basics of waves. So what is wave then? Wave is nothing but a form of disturbance. Any type of disturbance if created, then wave is generated or wave is also created. For example, I am talking now. So sound wave is created. So this disturbance in the medium is nothing but a form of wave. Similarly, if you put a stone on the water body, then you will see waves are created. So any form of disturbance is known as wave. And always remember, these particles of the medium are not traveling with the wave. They are just vibrating to and fro. That means simple harmonic motion, to and fro motion about their mean position. And then if particles are not traveling, then what is the quantity which is traveling or proceeding with the wave? That is nothing but the energy. So energy is transferred from one particle to other particle during propagation of a wave. So whenever we are considering a wave, that is nothing but a disturbance. So this disturbance is transferred from one point to other point due to the repeated periodic vibration of the particles. And these particles always transfer energy to its neighboring particles. So let's go to the topic. So here you can see motion. It is nothing but a form of disturbance. So here you can see the particle of the medium vibrates to and fro. That is simple harmonic motion about their mean position, and only energy is transmitted from one particle to another particle during the vibration or during the motion. Then what are the characteristics? So characteristics means what are the properties of wave. So already we discussed that wave is nothing but a form of disturbance. And when wave travels in a medium, all the particles of the medium execute simple harmonic motion. For example, if you consider in wave, and this particle will execute simple harmonic motion. This particle is also execute simple harmonic motion. So all the molecules of the particles, you can see they will vibrate to and fro motion about their mean position, and only energy is transmitted through the wave. And always remember that wave velocity is completely different from the particle velocity. So particle velocity is the velocity with which all these particles are vibrating to and fro motion about their mean position. Already we discussed in the previous lectures. Velocity equal to r omega cos omega t, that is the particle velocity. But wave velocity is the velocity with which wave is traveling or wave is proceeding in the medium, which is always equal to velocity equal to nu lambda. Because if you consider the distance from here to here, this will be lambda. So lambda distance is traveled in t time. So velocity will be lambda by t, and 1 by t is nothing but 1 by t. Directly we can write here nu. So wave velocity is constant for a wave in a given medium, because it is a product of lambda and nu lambda. But particle velocity is different for each particle. Again, you can see whenever wave travels from one medium to other medium, if two different mediums are there, air and water is there, and one wave is traveling from air to water, or you can say water to air, then you can observe all the property of the wave changes except a single property, which is known as its frequency. So these are the characteristics of a wave. Then types of waves. Let me explain first what are the types of waves. Waves are classified into different categories. One of them is mechanical wave. Then what are mechanical waves? So mechanical waves are those which require a material medium for their propagation. That means material medium is necessary. Without medium, these waves cannot travel from one point to other point. Best example is sound wave. Sound wave, since air is there, atmosphere is there, we are talking, and sound wave is traveling from one point to other point. So all these type of waves which require a material medium for their propagation are said to be mechanical wave. And these mechanical waves are also classified into or divided into two categories. One is transverse wave, one is longitudinal wave. So what are transverse wave? Now where the wave propagates like this, wave motion is in forward direction and the particles are vibrating. You can see the particles are vibrating perpendicular to it, where the particle vibration and direction of propagation of the wave. So wave is propagating in forward direction and the particles are vibrating along y-axis, wave is traveling along x-axis. So the angle between them is 90 degree. Since this is perpendicular to each other, this is said to be transverse wave. And in longitudinal, the particle vibration and the wave propagation both are along the same direction, so they are said to be longitudinal. And this is the example of motion of a spring. Or if the examples of transverse waves are light wave is transverse in nature, and you can see the waves created in water bodies are transverse in nature, but longitudinal wave example is sound wave. So the difference between transverse and longitudinal is that transverse means where the particle vibration and direction of propagation are perpendicular to each other, and longitudinal means where the particle vibration and direction of propagation are along the same direction. Similarly, the other types are, one is electromagnetic wave. So electromagnetic waves means, from the name you can identify, which contains both electric field vector and magnetic field vector. They are said to be electromagnetic waves. So the waves which can propagate without any medium, that means they can propagate with medium and without also any medium, they are said to be electromagnetic wave. So best example is, you can see light. Light is electromagnetic wave. So light is traveling from sun, so in between there is empty, that is space. So in space also light is traveling from sun to surface of earth. So this type of waves which do not require a medium for their propagation, which can propagate with medium, which can also propagate without any medium, are said to be electromagnetic waves. Then what is matter wave? You must have remembered the de Broglie wave. De Broglie wave wavelength lambda equal to h by p, or you can write down h by mv. So all the material particles in motion are always associated with a wave-like structure. Those type of waves are said to be matter waves. So these are the different types of waves. Next we will discuss about wave equation. That each particle of the medium always execute simple harmonic motion. So we can write down y equal to r sine omega t. This is the displacement of each particle, where r is amplitude, omega is angular frequency, t is the instantaneous time. If phi is the phase difference, we can write down like this, omega t minus phi, where phi is the phase difference. Now to modify it, so but we know that phi equal to kx, where k is 2 pi by lambda into x. Similarly, omega angular frequency is equal to 2 pi nu. So in case of nu, we can write down 2 pi velocity divided by lambda, because wave velocity equal to nu lambda. This is the formula already we discussed, that is wave velocity. So now we have to put these values here. So we can write, so this will be y equal to r sine, in place of omega we can use this value 2 pi v by lambda, minus, in place of phi you can write this omega t, and in place of phi you can write down 2 pi by lambda into x. Now you can see on both term we have a common quantity, we can take that outside. So 2 pi by lambda in bracket we have vt minus x. So this is wave equation. Now we have to find out the differential equation of wave motion, or you can say the differential form of wave equation. Already we derived the wave equation in the form of y equal to r sine, in bracket we have 2 pi by lambda in bracket vt minus x. This is the equation we get. Now differentiating it, with respect to x. If we take derivative with respect to x, what will happen? Now this is dy by dx. R is constant, then derivative of sine theta will be cos theta 2 pi by lambda Vt minus x. Again we have to multiply this constant 2 pi by lambda, and negative sign will be there because minus x. Now if we take double derivative d square y by dt square, then it will be r, and cos theta derivative is minus sin theta, sin 2 pi by lambda Vt minus x, and again this will be minus 2 pi by lambda, so minus minus plus, so 2 pi by lambda square, equation number 2. Now we take single derivative with respect to x, double derivative with respect to x. Now we have to find out derivative with respect to t, with respect to time. If we take with respect to time, dy by dt, derivative r constant, sin theta derivative is cos theta, so 2 pi by lambda, in bracket we have Vt minus x, and derivative of this will be 2 pi by lambda into v. Again double derivative d square y by dt square, this will be r, cos theta derivative is minus sin, so sin 2 pi by lambda Vt minus x. Again derivative of this whole term with respect to t will be 2 pi by lambda into v square. Let's give it equation number 3. Now we have derivative of y, double derivative of y with respect to t as well as with respect to x. This will be x, not t. This is x. Okay, double derivative with respect to x and double derivative with respect to t. You can see equation number 2 and equation number 3. You can see on equation number 2 we have r minus r, here also minus r. Here we have sine 2 pi by lambda Vt minus x. Here also sine 2 pi by lambda Vt minus x. Here we have 2 pi by lambda square. Here we have 2 pi by lambda v square. So the difference between them is a v square. So if we compare equation number 2 and 3, then we will get like this: d square y by d t square equal to v square d square y by d x square. Or you can also rearrange, you can write d square y by d x square equal to 1 by v square d square y by d t square. So this is known as the differential form of wave equation, where it states that the double derivative of y or displacement vector with respect to time is equal to velocity square times double derivative of y with respect to displacement. So if you have any doubt, any question, you can let me know in the comment section. Next I will do some numericals here, and I will give you some numerical to practice, and what type of video you need, just let me know. Thank you.